Welcome to one and all present here. Today I will be giving a brief introduction on the application layer. What is the application layer? It is the topmost layer of the TCP/IP model. This topmost layer is used to provide services to users around the world. This protocol is not to provide services to any other protocol but only to the protocols in the transport layer. This makes it very easy to remove in later stages as well. There are two types of protocols: standard protocols and non-standard protocols. Standard protocols in the application layer are those standardized and documented ones by the Internet Authority. It is used to interact with the internet as standard application layer protocols. When we use the browser to send a request, to send a question, if a user wants to ask some question, the question is being sent in the form of request. To send this request to the server, certain rules, certain protocols are being used. These protocols are the standard protocols. Now, non-standard application layer programs or protocols are those which are created by the programmer by writing two programs that provide services to user by interacting with the transport layer. Now, the application layer has paradigms, two types of paradigms, which are client-server paradigm and peer-to-peer paradigm. In client-server paradigm, it is the traditional model where the server provides services to the client processes over the internet. Now, if the server runs continuously, awaits the client request, while the client processes starts only when the service is needed. For example, in olden days, there were phone books in which users had to go through it to know the other person, the numbers in different numbers of different people in the same locality. It was hard because only after a single person uses it, only then they could use it. That was a big problem. Even though it had drawbacks, people used to use it. Now, in the current scenario, if I have to say, if a person requests, if so many people request for some kind of interaction from some kind of service. Now, here in the internet, everyone requests for some kind of interaction. This will overcrowd the internet and makes it slow. Only if the request gets its response, it starts working. That is a major limitation of this type of paradigm. But it is widely used by World Wide Web, HTTP, FTP, SSH and email. Now moving on to peer-to-peer. Peer-to-peer paradigm eliminates the need for central server and distributes the responsibilities among peers. For example, now if a team is being formed for creating a web application, one person is handling the front end, one person is handling the back end, one person is handling the database. It is easier for having work done since it is distributed. Later on, only integration is required. But instead of that, if only one person is working, it is a major task and everyone has to wait until one task is over to go to the next task. Peer-to-peer is similar to team formation. It divides the tasks and does work accordingly. Example is Skype, internet telephony. Then moving on to client-server programming. Client-server paradigms, communication occurs between two running applications application programs called client and server. Client initializes communication by sending a request, while the server waits till the request is received, processes them, sends response back to the client. Then comes the application program interface. Client server communication. This requires process at the application layer to interact with the lower layers of the TCP/IP protocol suite. To achieve this, a set of programming instructions called as the API, application programming interface, is used. API acts like a middleman where it stands between the application layer process and the operating system. There are three commonly used APIs: socket interface, TLI, transport layer interface, stream. Now, sockets are treated like other sources. Now, it's like, for example, a keyboard or file or anything, or a monitor or file. In the programming language, they allow the programs to send or receive data over the network just as they would with the standard input-output operation. Now, if you see this figure, socket is placed between the application layer and the transport layer. So whatever is given inside or whatever is given outside, it goes through this one socket interface. Socket used the same way as other sources and sinks. So now look at this. Keyboard sends in, it is getting read. Monitor gets the written response. Files get read, then it is written. So this is how socket works. Syncing in what is given in as input and source is being written onto the socket or given to the socket as output. Now, socket can act as communication endpoints for exchanging requests and responses between the client and server process. It can have two perspectives based on whether it is on the client side or on the server side. Now, socket appears as the entity that receives response to its request in the client's perspective. In the server's perspective, it appears as the entity that sends the request. Now, moving on to the socket address. The socket address has two parts that identifies us. Firstly, it is the IP address, then the port number. Like mentioned before, the IP address is the unique identifier that identifies a computer on the internet. Port number identifies the specific application program, whether it is a client or server on the computer. Now, finding a socket address. Socket address, it depends on whether it is on the server side or the client side. Server needs a local the server and a remote, that is a client socket address for communication. Now, local socket address is provided by the operating system and it is standard and well-known port numbers are being used. Remote socket address. Remote socket address is corresponding to the client's address making the connection. In the client side, local socket address is the client's local IP address which is provided in the operating system. Temporary port address is assigned by the OS for each client process, ensuring it is unique. Remote socket address. Client must know the server's socket address to initiate the communication. Without the server socket address, it cannot initiate the communication. If only the port number is known, the IP address is resolved using the DNS, domain name system. DNS functions like a telephone directory, mapping server names to IP addresses, enabling client to find servers for communication. Now, using services of the transport layer. For using services of the transport layer, application layer processes communicate via some protocols. These protocols are UDP protocol, TCP protocol, and the SCTP protocol. UDP protocol provides connectionless, unreliable, message-oriented datagram systems. The message is being given importance, which means it is independent, no logical connection between packets. It can be given messages or data is being given priority. It prioritizes simplicity and speed over the reliability, and gives importance to multimedia and management applications. Moving on to TCP protocols. TCP protocols are connection oriented, reliable, and byte stream services. Uses handshakes to establish communication parameters, ensuring data continuity through byte numbering. That is why byte stream service is used. It is ideal for application requests requiring long messages and reliability, but it lacks message oriented boundaries. Now, data can get mixed, unlike in UDP protocol. UDP was unreliable and it prioritized only data. Here, that is not there. Now, SCTP protocol. It combines TCP and UDP by offering connection-oriented, reliable, and message-oriented services, supporting multi-streaming for multiple network layer connections and maintaining communication even during partial network failure. Even when there is an internet issue, it supports the communication. It is suitable for application needing reliable and multi-streaming capability. Thank you.